And welcome to this next question. This is question number 4 for Edexcel's C4 January 2009 paper. Okay, so we're given these two vector equations of lines. Okay, so we're told that line 1, the r, which is denoted by the position vector, is equal to 11 to 17, so that's a point on the line, plus lambda lots of the direction vector, minus 2, 1, minus 4. Okay, and we've also got another line, line 2 obviously, where same sort of principle, r being the position vector, and then the point on the line is minus 5, 11p. Obviously we're going to have to work out p at some stage, weirdly enough. Okay, plus mu lots of the direction vector, q, 2, 2. Okay, so the first thing that we're told, okay, is that where lambda and mu are parameters, basically just means something. It means we can sub a number into lambda and mu, okay, and p and q are constants, so these two are basically just numbers. Alright, given that L1 and L2 are perpendicular, show that q is equal to minus 3. Well, when two lines are perpendicular, their dot product is 0, okay, and that's essentially because, say when we've got, say this is line 1 and this is line 2, okay, if we're measuring this angle, it's the distance at the this line here, so the top of the line has to go down, okay, and then it's that distance there. Call that distance x, okay? And if they're perpendicular, then obviously the line down from the top of L1, obviously L2 or one of the lines, we know the lines are technically infinite, but if we chose one of the points, okay, and drew a line down from it, this distance is what we'd be measuring, okay? And if they're perpendicular, then obviously this line will be perfectly horizontal, so this distance will be 0. Okay, so that's just a kind of a brief reminder of why we can use this dot product, okay, to be 0 when two lines are perpendicular, okay. But when we're looking at perpendicular, when we use a dot product, we have to use two vectors. Now we can't use a point on the line because technically they're not going anywhere. It just says a point, okay. We need a direction vector. And the only direction vectors we've got minus 2, 1, 4 and q, 2, 2. Okay, so you need to know the dot product of them two is equal to 0. So that's the first thing that you would state. Okay, so minus 2, 1, minus 4 times by q lots q, 2, 2, and we are told that is equal. Well, you should know that is equal to 0. Okay, so I mean the first thing that I would state in a little explanation of some kind of paragraph or whatever you want to throw together, just say that when the dot product is 0, they are perpendicular. Okay, you don't have to do that, but it makes you look that little bit smarter. Okay, so the first thing you would do is minus 2 times q. Okay, and you add that to 1 times 2, and then you add that to minus 4 times 2, and you put that all equal to 0. Okay, so if we simplify each term now, well obviously we get minus 2q plus 2 plus 2 take 8, okay, and if you simplify that down, see that's equal to 0. Okay, so minus 2q, I've done this right. Yeah. Sorry, yeah, I've done this right. I was thinking of that one. Is equal to 6, okay? So therefore, you divide both sides by minus 2, you get q is equal to minus 3 as required, okay? And it says, show that q is equal to minus 3. So that's what you've done. We'll call that part A, okay? Alright, so a very, very simple start to this question. But question B, part B says, given that L1 and L2 intersect, find the value of P. In other words, find this number here. Okay, now the first thing I would do is, well, write in what Q is. So just about Q, write the line again, put Q to be minus 3. Okay, so what do we know about lines intersecting? Well, obviously from really simple math knowledge, say this is equal to y, that's equal to y, we let y equal y, or in this case r equal r, okay? So you put the first line equal to the second line, so nothing extreme what we've done so far. So 11 to 17 plus lambda lots of minus 2, 1, 4, okay, is equal to minus 5, 11p plus mu lots of minus 3, 2, 2. Okay, so now it's just coming up with, obviously we don't know what mu and q are, but we're going to need to work them out to be able to give us a value for p, which is what we're trying to work out. Okay, so like any other equation where you vector equation, where you'd be working out a point of intersection, you come up with your simultaneous equations. So the first simultaneous equation is comparing the x components of either equation, or in other words, the I components. Okay, so the first equation therefore is equation 1, 11 take 2 lots of lambda is equal to minus 5 take 3 lots of mu. Okay, equation 2 is obviously comparing the j or the y's, okay, which is 2 plus 1 lots of lambda, okay, so 2 plus lambda is equal to 11 take plus 2 mu. Okay, so there's your first two equations. Then they're what we're going to be focusing on to rearrange, okay, because obviously this equation 3, we've now got 3 unknowns in this, and it's going to be quite tricky to rearrange this, okay. So when we compare the k components, okay, or the z is 17 plus should be minus 4. 17 take 4 lots of lambda is equal to p plus 2 lots of mu. Okay, so what we're going to do is rearrange. Now we're going to sort of modify and substitute down or take away, whichever you want to do, to get a value for lambda and mu, which satisfies both equation 1 and equation 2. Now, for the moment, I'm just going to ignore equation 3, because obviously we've got 3 unknowns here, lambda, p and mu. I'm also trying to work out p, so if we could work out p straight away, there's no point faffing around with all this business. But we're told the intersect, and that's kind of a key bit really here. Okay, now the easiest one of them two, because I'm lazy, to rearrange to get one in terms of the other, it could be lambda in terms of mu, or mu in terms of lambda, is quite clearly going to be equation 2. Okay, as I said, you can do that with equation 1, but I'm lazy, so I'm going to use equation 2. Okay, and there's no, in that shed, you can't be either. Okay, so it's lambda equals, or we take 2 away from both sides, which quite clearly gives us 9 plus 2 mu is equal to lambda, and we sub that in to equation 1. Okay, so equation 1 says 11 take 2 lots of lambda is equal to minus 5 take 3 lots of mu. Okay, sorry, it's a bit of a mess on the board here. High-tech rubber. Okay, so what we're going to do is sub this other equation 2, which I'm going to call now equation 4, rearranged equation 2. So lambda equals 9 plus 2 mu. Okay, I'm going to sub that into equation 1. So 11 take 2 lambda is equal to minus 5 take 3 mu. Okay, and lambda is equal to 9 plus 2 mu. Okay, so 11 take 2 lots of 9 plus 2 mu is equal to minus 5 take 3 mu. Okay, so then it's just a case of expanding this out. I said you might have done that already, but you know I'm probably going to make a mistake if I tried to skip a step. See, I already did that. Okay, so 11 take 2 mu, and then we'll see. Oh, I mean, I've already made God's sake. 11 take 2 times 9, which is obviously 11 take 18, take 4 mu is equal to minus 5 take 3 mu. Okay, so rearrange that. Well, obviously that gets us minus 7 take 4 mu is equal to minus 5 take 3 mu. Okay, so rearrange, add the 5 to both sides, and add the 4 mu to both sides, which obviously gets us mu is equal to minus 2. Okay. Now, that's what mu equals. And we also need to, so now we can sub mu into equation 3. But we're still left with 2 unknowns there. We're still left with lambda and p to be 2 unknowns. Obviously, p is going to be the one that we work out last. But still, if we subbed mu to be 2 into equation 3, as I said, we'd still be left with 2 unknowns. So we can't work it out just yet. We've got to work out what lambda is as well. Well, we've got this equation 4 that we came up with before that says lambda is equal to 9 plus 2 mu. Well, we know what mu is, so we can sub it into this equation 4. Okay? And therefore, we can use our value of mu to give us lambda. High-tech stuff. Okay, so because I'm crazy and I'll do it in red, it's the blood in my anyways, but don't tell them that, it's just a whiteboard pen. Okay, lambda is equal to 9 plus 2 mu, mu being 2, so it's obviously 9 take 4, which is obviously 5, so lambda is equal to 5. Now we've got lambda is equal to 5 and mu is equal to 2. So we've got our two unknown variables now. As I said, what we could do is work out the I and j components, okay, of the intersection, but we're not being asked to do that. All we're being asked to do in part B is simply work out the value of p. So we're doing most of the work for part C, which asks us to find the coordinates of the intersection. But as I said, all we've got to do in this part B, okay, is work out the coordinates, so the point of the value of p, okay. So as I said, now we've got a value for mu and now we've got a value for lambda, we can put it into equation 3, okay, which says 17 take 4 lambda, and we know lambda is 5, so 17 take 4 lots of 5 is equal to p, which we don't know, plus 2 lots of mu, which is minus 2. Okay, so simplifying this down, obviously, therefore we get minus 20 on the left hand side is equal to p take 4. Okay. Have I done that right? Oh, sorry, not minus 20. Where am I going on from? Sorry, it's 17 take 20, which is obviously minus 3. Do apologise, I can't do basic math, so I'll shoot myself. But you're still watching the video if you're listening to this, obviously. I'm going to be one of them more instances. If you're still watching this, which obviously, you know, by the power of logical deduction, if you didn't hear that, you wouldn't be watching it. You know, but that's just humans for you. Sorry, okay. Right. So we've got minus 3 is equal to p take 4. So as I said, it's just a case of, I've made some hideous mistake of 2 lots of mu. Sorry, I do apologise. What is that? Let me just double check my answers. Sorry, I just clearly don't have enough faith in myself. I was right. Okay, so if we rearrange this, obviously we get p to be 1. Okay, and that's what it's asked for. We've got a value of p to be 1. We've got okay, so we've got lambda to be 5, p to be 1, and mu to be 2. Okay, so you just write that somewhere else at your side of your page. Okay, so lambda equals 5, mu equals minus 2. These are the points of intersection. Okay. So when they intersect, lambda is equal to 5 and mu is equal to 2, and you might want to rewrite this out and write p to be obviously 1. Okay, so that's part B over and done with. Okay, now part C, well, we've already done most of part C. It asks us to work out the coordinates of a point of intersection. But we know, because obviously to work out p, we had to work out the intersection. Okay. Almost, but what we did in that, as I said, we worked out the value of lambda and mu when they intersect. Okay, so quite clearly you can pick either line because we've got the value of the constant, either lambda or mu, associated with line 1 or line 2, and we just simply sub that in because we've got now all the known values of each line. Okay. And now naturally, because you've been working with line 2 for so much, trying to work out what Q was and then work out what P was, okay, naturally you'd want to use line 2. And there's no reason why you couldn't. I kind of set it up to do the opposite, but you know, watching the X Factor as a little kid, and then when I was able to switch off the remote, I switched it off and blew up the TV. But anyway, beside that, okay, so as I said, doesn't matter which line you choose, I'm just going to choose line 2. Okay, the position vector, which is the point of intersection, minus 5, 11, 1, and we're adding mu, which is minus 2, so in other words we're taking away 2 lots of minus 3 to 2. Okay, so it's just a case of, you know, doing your standard multiplication out and subbing it up. Okay, so it's minus 5, take 2 lots of minus 3. Okay, in other words, minus 5 plus 6, which is quite clearly just going to give you a value of 1. Okay, so that's your first component, your I component, it's just 1. Okay, and then it's 11, take 2 lots of 2. Okay, so in other words, it's obviously 11, take 4, which is quite clearly going to give you 7. Alright, and then it's 1, take 2 lots of 2. Okay, so it's obviously minus 3. So that's your position vector 1, 7, minus 3, or I plus 7j take 3k. But as I said, I prefer to leave it in column vector form because most calculations kind of are easier to use in column vector form. Okay, so that's the end of part C. Now this part D is where it gets a little bit more tricky, and the only reason it gets a little bit more tricky is through the wording of the question, but I'm going to try and break it down so it's kind of understandable. And it's probably easier of those that you find vectors hard if I spoke French. But unfortunately my French is quite limited in terms of you know, une bière, you know, not alcoholic stuff. Anyway, going back to my lifestyle choices and applicable demise and future death. Okay, so anyway, we're told that point A lies on L1. Okay, so this is point A. We're told the coordinates of point A. Okay, so I'm going to tidy this up a bit. Okay, so we're told the coordinates of point A are 9, 3, 13. Okay, and that lies on L1. Okay, so as I said, it's a good idea just to note down all of the bits of information that you've got. Okay, so this is now part D. Okay, so we're told that A lies on L1. The point C lies on L2. But what is C? Well, given that there's a circle with a centre C, well, this point C, the centre of the circle, lies on L2. Now, what is a good idea, and always what I try to emphasise on vectors, is draw a sketch. Now, I haven't drawn a sketch just yet, because, I mean, as I said, there's not really been any need for it. Okay, so what I'm going to do is a basic kind of sketch here. So, I don't know if line 1 and line 2 look exactly like this, but obviously they're going to intersect at some point. And we worked out to the intersection to be 1, 7, minus 3. I'm going to call that point X. Okay, and obviously that's where they intersect, so it's right there, which is, we said, is 1, 7, minus 3. I'm going to call that point X, as I said, because it's a point of intersection. Okay, we're told that point C lies on L2. Well, this is L2. I'm going to call point C somewhere down there. Okay, we don't know the coordinates of point C, but we know it's the centre of a circle. And if that's the centre, then we've got obviously a constant radius. So it's going to look something like this. Please excuse my drawing. Okay, I mean, I know it looks like a tear-shaped blob, but you get the overall idea. So we've got a centre of a circle here. So that I've just drawn what we've given so far. And we're told that line 1 cuts the circle at points A and B. Well, this is line 1 and it goes through the circle at this point over here and this point over here. Well, this point here we call A, which is what we've just found out, what we've just been told, okay? So that's point A. And this other point we're told is point B, which we're asked to find the coordinates. Now, using the basic idea of circles that, so obviously, as I said, the main part of this really was sort of thinking about it. Now we know as a circle obviously has a constant radius, which means has a radius, anyway, shut up. Okay, so what I mean is the distance from A to what we call this point X of intersection is the same as the distance from this point of intersection to B. So as I said, you might want to note that down somewhere on your page. So the distance A to X, so the vector A to X, you can do the modulus of it if you want, is equal to the distance X to B. Okay, in other words, the change in the vector A to X, so A to X is equal to A to B. So therefore the distance A to X is the same as the distance X to B. We could just say that the change in the I and J and K coordinates components are the same when you go from A to X as you go from X to B. Okay, so quite a common question whether you use the line of symmetry, okay, in this type of question. Okay, so what we want to do is find the coordinates of point B. Now, we know the coordinates of point A. We know the coordinates of point X. Okay, but remember this is the distance O to A. This is not the distance A to X. So to work out, so what I'm trying to say is to get from O to B. Okay, so if we call the origin somewhere over the bottom right, okay, I'll put it down here. We'll call this the origin. Now you quite clearly know that's got the coordinates 0, 0, 0. Okay, and O to A, okay, plus A to x and x to b is the same as going from O to b. Okay. Now, therefore, we can come up with an equation. O to b is the same as going from O to a plus a to x. Sorry, plus a to x, and then when we're at x, we go from x to b. But because I said there's a constant radius, okay, so the changing the I, j, and k components from a to x is the same as changing the components from x to b. So because we've got a to x and x to b, what I'm trying to say is we can combine this to just say it's O to b is equal to two lots of a to O to b is O to a plus two lots of a to x. Okay. And the reason being for that, as I said, is because the distance, the changing the components from a to x is the same as x to b. We don't know, as I said, we could have put that as 2xb, but we don't know the distance. We don't know the change in the I, j, and k components of the vector from x to b, so it'd be pointless putting that in. But we do know, we don't currently, but we can by all means dare use some bit of maths in a maths exam. Imagine that, to work out that or whatever we need to work out. Okay, so really what we need to do is work out this equation. Now, obviously we know O to B, we know O to A, but we don't know O to X, but we can work it out. So as I said, you might want to do this. So as I said, depending on how much space you've got, well, as I said, you could create space, ask for some more paper, as I normally use all the trees, probably kill a few rainforests or whatever, okay, on my way through the exam. So obviously we need to work out A to X. And as a standard thing from when you go from one variable to another, okay, it's the negative O to A plus O to X. Okay, well, O to A is this formula over here, and O to X is just the position vector of X. Okay, so A to X is equal to the negative of O to A, so negative 9, 3, 13, plus O to X, which is 1, 7, minus 3. Okay, and that's just a case of simplifying this down. Well, it's minus 9 plus 1, which is quite clearly minus 8, and minus 3 plus 7, that's quite clearly 4, and minus 13 take 3, which is quite clearly minus 16. Okay, so that's A to X. Now we know O to A, we know A to X, so we just sub in our values into this O to B equation. Okay. Okay, so O to B is equal to O to A. So basically we're here, we want to get to B, over here. So we go O to A plus A to X plus X to B. And we said X to B was the same as A to X, so we can just put two lots of A to X as we don't know X to B. And we've just worked out A to X, and that's O to A. Okay, so it's just subbing in the vectors to this equation. Okay, so O to B says equal to O to A, which is 9, 3, 13, plus two lots of A to X, which is 9, 3, we're going about A to X, minus 8, 4, minus 16. Okay, so obviously just compare now the I, J, and K components. So it's 9 plus two lots of minus 8, in other words, 9 take 16, quite clearly. Okay, and if you do sorry, I do apologise, bit of a cough. That's minus 7, okay, and then your J component is 3 plus 2 lots of 4, in other words, 3 plus 8, which is quite clearly 11, right, and then it's 13 plus 2 lots of minus 16, well, so 2 lots of minus 16 is minus 32, so it's 13 take 32, which is minus 19, okay, and that is your position vector B. Okay, the coordinates of B, O to B. Alright, so hopefully that kind of explained it to you in a simplified kind of way. But as I said, that was a very, very difficult vectors question. And especially for number 4, I would have expected that particular vectors question to be a lot further on in the paper. But really, the majority of you hopefully should have been able to understand without having to resort to this video hopefully up until the point maybe part C. As I said, part D was only worth 3 marks, so it's not the end of the world if you couldn't answer that last part of the question. But really, it's just being able to, with these questions, it's reading the question, trying to draw a sketch and trying to imagine it in your head. Okay, I didn't do this particularly well. I think I made just a few miscalculation errors. But as I said, if you get the main method, it's the majority of the marks anyway. Okay, so hopefully try to explain it thoroughly. Now, the thing that caught me out, apart from the fact I can't annotate, is the fact that it said point C and then it says the curve has a centre C. It's almost as though they're two separate points. Well, obviously they're not, as I've quite clearly labelled on there. But as I said, it's just a key thing to watch out for. Obviously, point C is the same as centre C in the circle, as it's listed in the question. As I said, don't get too worked up about that. Okay, so thanks for watching. Hopefully you've been able to understand what I've been going on about and waffling on about and wasting your entire life. So good job for wasting your life, and we'll see you in the next video. Thanks for watching.